In this video, what I want to show is what happens when different materials are heated and then placed in a vacuum on a scale. Because I've seen what looks like gravity modification in these different materials in atmosphere undergoing temperature changes, the logical thing to ask is, does this happen or work in a vacuum? So if you watch this video to the end, you'll see a few examples of different materials that undergo a change of their weight over time as their temperature changes inside the vacuum chamber. So this bowl of sand has been heated to 124 degrees Fahrenheit, and it's indicating there 18% relative humidity. So what you'll see is a sudden change in weight while the air is being pumped out. And then there should be a sort of baseline weight, a positive weight that you'll see due to the air that was displaced when it was weighed under 1 atmosphere. In other words, that would be the buoyancy force manifesting. In case that's not clear, that's reading 150.9 Fahrenheit, 17% humidity. I just want to point out that at the time of this recording, I didn't realize that the quality of vacuum that I was getting wasn't as good as I thought. So after getting some new gauges recently, I found out that the vacuum I get is not according to the spec on the pump, which is 0.3 pascals, but it's more like maybe 30 or 300 pascals, which is still a low pressure, but it's not a high vacuum. Here I will put the camera under time lapse. Notice how the reading on the balance is 1.01 grams. It is steadily increased at 128 degrees Fahrenheit. This time lapse went a lot faster than I wanted it, but here you can see the changing, you'll see the weight steadily go down over time. The light in the room went out automatically, so that was also unwanted. I forgot to leave the lights on. So this is somewhere around a half an hour of time that's going by here. So clearly there was a peak there, and now it's returning back down again as the temperature decreases back down towards room temperature. So if we think about the total volume of air displaced by the bowl and the sand, if it was completely full, would be about 900 milliliters times the mass of air at sea level, which is 1.08 grams, but the bowl is only half full, approximately. So I believe what remains there on the scale is the weight of the air that was displaced by the volume of the bowl with the sand in it. So it seems as though temperature has affected the gravitational mass of the sand. Okay, I got a piece of brass here weighing 790.95 grams, and I've heated it up well over 100 degrees Celsius. I'm going to put it in here and weigh it as it cools in a high vacuum. Hopefully nothing goes wrong here. So 790.95 grams I weighed cold after calibrating the balance. So Let me just pump the vacuum here. So now you'll begin to see it approach a peak, which is far beyond the expected increase in weight due to buoyancy. So in this case, there's about a half a gram or 0.5 grams increase or peak from the starting point when I first pulled the vacuum. So I measured the volume of the brass cylinder to be about just under 100 milliliters. And the way I do these measurements is by displacement of water in a graduated container. So displaced air of 100 milliliters would weigh about 120 milligrams or 0.12 grams, which is much less than the displayed increase. And still under vacuum. Still very hot. Quite hot. That's not right. Low emissivity. Let's check this. This is kind of warm. 26 degrees. 28. It's slightly warm. Very slightly. That's what it weighs. It's getting pretty close to the original weight. Let's see what the calibration weight says. What does the calibration weight say? Survey says, looking pretty good. Pretty darn close. Here's a different weight. 500 grams. Oh yeah. So that tells me that even though this is slightly warmed, a little bit of heat conducted through here, probably into the plate, but it's still weighing very accurately. I'm going to do this experiment again. And this time I'm going to use this on the plate. I'm going to try this graphite crucible. It's now pretty hot, 124 degrees. I will stick it on here to 17.97 currently in atmosphere. Now approaching full vacuum. That's good enough. Okay, 10x speed here. Okay, 35 minutes later. Looks like a bit of a drop. I want to see if it's still hot. It should be warm. It's still pretty warm. It's warm, but it's not hot. So it's cold. Next up is this bowl of crushed charcoal briquettes. I had this sitting around and I thought it'd be interesting to try. So that's reading about 200 degrees Celsius right now. You can see there the layers of material. That's glass, cardboard, and a can, just to provide layers of thermal isolation. I had to cut this test short because the battery on my balance was running out. But it should have been fairly evident that indeed it was gaining weight to the tune of about 0.3 grams as it was cooling down. So there's still a ways to go here before it was back down to ambient temperature. On this channel, I'm focused on unlocking the secrets of gravity, inertia, for new kinds of propulsion, and over unity electrical power systems. Hope you find these experiments interesting and educational. If so, remember to show your support with a subscribe and a share, and make reference to this channel if the data, research, or information and ideas are helpful to you. Thanks for your support.